Here's a fun one that was recommended by several people. Write a function that returns true or false, indicating if its argument, a string, is a palindrome. And a palindrome is a string that reads the same backwards and forwards. So like madam is a palindrome. And also you can say, madam, I'm Adam, a famous version. If you take away all of the spaces and you make everything lowercase also, I guess it doesn't really matter in this case, right? But you can see that's also a palindrome, reads the same backwards and forwards. So let's do this. I'm going to say here def is, check palindrome S. So how can we do this, right? Well, first of all, here's the easiest solution. The easiest solution is to say return S equals S colon minus 1. That's not going to cover all the bases, but it's a lot of them. And how is this really going to work? Well, obviously S here on the left, fine. But what is this S colon minus 1? So if I say here A, B, C, D, C, B, A. So if I say S of colon minus 1, that means from, well, basically all characters, but step size of minus 1. Which really means we're going to reverse it. Now you can't see it there, so let's actually just say A, B, C, D. It's kind of hard to see if you reversed a palindrome. D, C, B, A. So now remember that this colon minus 1, it does not change S. It returns a new string based on S, or based on the slice of S from the start to the end, step size minus 1, or more technically from the end to the start, step size of minus 1. So what we do here is we say, what happens if I want to check, is the string equal to its reverse? Okay, like definitely not a bad way to go. All right, and that will certainly work. Actually, I might as well keep this here. But there are some holes. Like what if I say here, S equals madam, I'm Adam. And now I say check palindrome on S. And it's going to say, sorry, right? Like it's false, even though we know that's true. Well, what's the problem there? The problem there, of course, is that it has spaces, it has punctuation, it has uppercase letters. So how can we fix that? Well, now we're going to have version 2 of our function. Right? So version 2 of our function is basically going to say, well, what we've got to do now is like change some things here. So I'm going to do this. I'm going to say here, S equals, well, what do I want to do? I want to just like remove anything that's not a printable, not a character, not a letter. And I also want to make it all lowercase. So I'm going to say S equals S dot lower. Okay, so far so good. Now we've gotten rid of, now we've gotten rid of the whole capitalization business. And then I'm going to remove everything that's not a letter. Well, how can I do that? Well, remember, assuming you're doing these exercises in order, in a previous exercise, I could do S dot is digit. Well, it turns out there are a whole bunch of is methods that we can use. S dot is, okay, right? If I do a dir on S, we're going to see there are a whole lot of different methods we can use. Is, here we go, alpha. That's what I wanted. Okay, so if I say here, S dot is alpha, well, now it's going to say false because S contains some of these things. But what I can do is go through each of the characters. And if is alpha is false, then ignore it. I'm only interested in those that are is alpha true. How am I going to do this? List comprehension, of course. So I'm going to say here, S equals join on, and I'm going to say here, one char for one char in S if S is alpha. Let's do a print here of final S equals S. And now you'll see that when I run it, if I say now check palindrome of S, it's going to say madam, I'm Adam. Oh, wait a second. It did seem, is alpha seems to have included the commas there. Let's take a look at is alpha. Oh, an alphabetic string. One character in the string. So if I say here my mistake. I forgot the parentheses. There we go. Much better. There. I say one char. Boy, it's not my day, is it? There we go. Much better. So basically what we're doing is we are checking each character. Is it alphabetic? Is it a letter? And if so, then we're letting it go through. And this is once again using a generator expression. It's like a list comprehension, but a bit more efficient in terms of the memory, because only when the caller asks for each additional element is it going to be passed. So join this way allows us to basically go through one by one each of the characters, join it to a new string. We're putting nothing between each of the characters, which means basically we're getting the string, each of these characters without white space. And then S is there. We print it out just so we can be a sort of happier with ourselves, and it all works. Question for you. What if I try this now with a non-English string? What if I say here something like S equals, right? What if I say here in Hebrew, Aleph, Bet, Gimel, Bet, Aleph. Right? So it's not in English, but it is a palindrome. It's also nonsense of S. And it's going to say, yes, it is actually true. So there we go. The final S was actually included all of the characters there. What if I say here like some spaces and maybe some exclamation points, right? It's once again going to say, no, I'm only interested in the letters. So it's actually working. Is alpha is actually going to work pretty reasonably because it's looking for an alphabetic string, even if it's not ASCII letters there, even if it's from another alphabet. So that's another way that you can do this sort of checking. Regardless, I think it is useful to understand how strings work, how these generators work, how to move between join and split is super, super important. Checking your work, as I did here, maybe with some automated tests, which I'm not doing here in this course. And then at the end of the day, using our slice to return the equality between the string and its palindrome.